Let's say we have a sample of 500 nursing applications and 60 are from men. What is the best point estimate of the true proportion of men who apply to the nursing program? Find the margin of error that corresponds to a 90% confidence level, and then find the 90% confidence interval of the true proportion of men who apply to the nursing program. So in this example, what's the sample size N? $500. And what will be considered the success? What is what we are analyzing in this problem? That will be the number of success. So the success will be men in nursing. Okay, very good. So X is 60, the number of successes, and the success is that the application is from a man. So what will be the best point estimate of the true proportion of men who apply to the nursing program? We already know that the best point estimate that we can find, the best single value that we can use to estimate the population proportion is the sample proportion. And the sample proportion is X over N. The number of successes divided by the sample size. So 60 over 500, and that is 0.12. So this will be the answer for part A. 0.12 is the best point estimate of the true proportion of men who apply to the nursing program. In percentage, we can say that 12% of men apply to the nursing program. Now in part B, we want to find the margin of error that corresponds to a 90% confidence level. So the margin of error, the formula is the critical value Z alpha over 2 times the square root of P hat times Q hat divided by N. So in order to use this formula, we need the critical value Z, Q hat, and we already have P hat and N. So for a 90% confidence level, what's the critical value? In the last row of table F, %, so in the first row, we look for the confidence level. So in this example, the confidence level is 90%. So what's the number in the last row? 1.645. Okay, so this is the critical value that we're gonna use, 1.645. So the margin of error will be 1.645 times the square root of P hat, so P hat is 0.12, times Q hat. How do we find Q hat? Q hat, it will be 1 minus P hat. So 1 minus 0.12, that's 0.88. So that's the number that we're going to multiply here. And divided by the sample size. The sample size N is 500. So use your calculator and let me know what you obtain for the margin of error, round to 4 decimals. So what did you obtain? Yes, that will be the margin of error rounded to 4 decimals, 0.0239. And the last question is about the confidence interval. So for the confidence interval, we need the lower limit p hat minus the margin of error. So p hat is 0.12. The margin of error is 0.0239. So round to 3 decimals, 0.12 minus 0.0239. When you subtract 0.12 minus 0.0239 and then you round to 3 decimals, you should get 0.096. Yes, because at the end, we round to 3 decimals, so 0.096. And now the upper limit is p hat plus the margin of error. So 0.12 plus 0.0239. And then round to 3 decimals. So 0.144. So what will be the final answer? What will be the confidence interval? The confidence interval is a range of values between 0.096 and 0.144. Another way is to write it like this: 0.096 less than p less than 0.144. So these are different notations. So in the homework, you will see how to write the confidence interval using different notations. Sometimes you will use this notation, sometimes you will use this one. They are all equivalent, okay? We have the same problem from before. A poll of 1,487 adults showed that 43% of the respondents have Facebook pages. Find the best point estimate of the population proportion, P, of adults who have Facebook pages. Then find the margin of error corresponding to a 95% confidence level, and find the confidence interval, the 95% confidence interval. So we already did part A. So the best point estimate of a population proportion is the sample proportion. So when the information is given as a percentage, what's the sample proportion? If the percentage of people who have Facebook pages is 43%, then the sample proportion is 0.43. So we have the solution on the next slides. The sample proportion is 0.43. The margin of error is 0.0252. And the confidence interval is from 0.405 to 0.455. So how do we interpret the confidence interval? We say that we are 95% confident that the interval from 0.405 to 0.455 actually does contain the true value of the population proportion. Now, this is one way to interpret. Another way is use probabilities, because this 95% corresponds to a 0.95 probability. So another way to interpret the confidence interval is saying that the probability that the true proportion, the population proportion P, is between 0.405 and 0.455 is 0.95. So you convert the confidence level into a probability by dividing by 100 and say that the probability that the proportion is between these two values is 0.95. So this is a very high value for a probability. That's why we have a 95% certainty confidence that the parameter will be included in this interval.